Okay, so let's do another empirical formula example. We'll do B together. So the first thing is that we have percentages here, so the iron and the oxygen. So the first step when we're doing empirical formulas is just to convert the percentage to gram, aka change the percent to gram. So percentage, we're just going to assume is the same thing as gram, which can be a little bit confusing because in the first one it's in grams and then the second one is in percentage, but it's just the same thing. So we're going to assume we've got 72.36 grams of iron. So 72.36 grams of iron. Oh, come on. 72.36 grams of iron. And we're going to have 27.64 grams of oxygen. 27.64 grams of oxygen. Now, my next step is that I have to convert these to moles. Okay, so I've got to do my mole conversions. And remember, when we convert from grams to moles, we've got to use our average atomic mass from the periodic table. So I'm going to insert my equation. And I know I want to convert to moles, so my moles will be on top. And then on the bottom, I have to get my average atomic mass. So I got to pull up P table. And here is iron. Iron's 55.845 grams. 55.845. And it's just 55.845 because there's only one atom of iron. So it's just one, so we're just using the average atomic mass. Okay, so I'm going to go to my calculator and divide. So I've got 72.36 divided by 55.845. Okay, that's going to give me 1.296 or 295729. Since the least number of sig figs here is 4, for best practice, I'm just going to round it to 4. So it'd be 1.296. So 1.296, and that would be moles of iron. Okay, we're going to do the same thing now for oxygen. So 1 mole of oxygen should be a multiplication there because we are converting. So 1 mole of oxygen over, and oxygen is right here, and he's 15.999. So again, there's only one atom of oxygen, so we are going to do 15.999 grams of that oxygen. Okay, so the grams are going to eliminate, and it's going to leave me with my moles. I'm going to make this a little bit bigger because I know when I upload these to YouTube, it can look a little bit small. So 27.64 divided by that average atomic mass is going to give us 1.7276, etc., etc. So same thing, lowest number of sig figs here is 4. I'm just going to round to 4. So that's 1.728. 1.728. moles of oxygen. Okay, so now we are going to divide by the number with the least number of moles. Okay, so I have 1.296 moles of iron, 1.728 moles of oxygen. 1.296 is lower than 1.728, so I'm going to divide both of these by 1.296. Okay, so I'm going to do 1.296 divided by 1.296, which will just give us 1. And then 1.728 divided by 1.296. So when you get to this point, we are just dividing by the one with the least number of moles, so the least number of moles that we've calculated. So 1.728 divided by 1.296 will give us 1.33333. So it's a repeating 3. So 1.333. So here's the thing. This is unfortunately not one of those beautiful ones that comes out to to immediately give us the correct number of atoms that we'll need for each of these elements. So because we've got that 1.333, we've got to multiply it by a whole number to get it up to a whole number, or we have to multiply it by whatever will give us a whole number. Now, if it was a 0.5, we would multiply by 2. But because there's a 1.33 here, we're going to multiply it all by 3. Okay, because if we multiply by 3, it'll get us up to a whole number. Okay, so we'll multiply this by 3 and this by 3. Okay, so we'll have Fe3O4 because 1.3333 times 3 will give you about 3.9 and it'll round to 4. Okay, so this would be B. And then the same process you will do for C. If you still have questions, definitely let me know, but I hope that this was helpful.